And I think I'm going to change my order a little bit. I was going to do something first, but I think we're going to go dividing first. Okay, dividing fractions. I'm going to show you how very close it is to multiplying. Now, I don't know in your studies of dividing fractions, whether it's way back in your head in your memory, if you never heard it before. I never heard it before until I was a teacher because I wasn't taught this way, but it seems like today everyone I teach fractions goes, oh yeah, it's this. Okay. If you haven't heard it before, I'll explain it. If once I say it, you're going to go, some of you are going to go, oh yeah, I remember that. Okay. So when you divide fractions, a current thing that teachers teach is called keep, change, flip. Sound familiar?
Yeah, I heard of it.
Yeah, you heard it before, right? Okay, so yeah, a lot of teachers teach it this way today. I never heard it, like all of a sudden, one time when I first started teaching, they're like, oh yeah, it's keep, change, flip. Like, what are you talking about? Like, I never heard it that way before, but now I use it all the time. All right, what does it mean? It means that when we, actually, let me just write a problem down. 1/2 divided by 2/3. Hey, what does it mean? When you divide a fraction, you keep the first fraction, you change the sign. Instead of dividing, it becomes multiplying. That's because dividing is just multiplying, except you have to flip or reciprocate the last fraction. So dividing just becomes multiplying by doing keep, change, flip. So you keep the first fraction, you change the dividing to multiply, and you flip the last fraction. Only the last fraction. You do not flip the first fraction, only the last fraction. And then once you do that, we're just doing multiplying. So 1 times 3 is 3, 2 times 2 is 4. Done. So dividing fractions is nothing bigger than just multiplying. We just have to fix it first. So let's look at a couple. Practice. Since we got really good at multiplying, we can just go right to practice. Okay, 8/7 divided by 2/9. Now, we're going to do keep, change, flip. So I keep my first fraction. I change my divide to multiply, and I take, and flipping means reciprocal. I'm just going to flip it, which means reciprocal. So the 9 goes on top and the 2 goes on the bottom. Now you have 2 choices. You can look to see if you can cross simplify. I'm going to look to see if I can cross simplify, or just multiply across, and then simplify. So let me go look though. 7 and 9, I can't do anything with that, but I have 2 and 8. 2 and 8. I can divide both of them by 2. So that becomes 1. That becomes 4. And then now I know I can cross multiply. 9 times 4 is 36. Over 7 times 1 is 7. And then I'm going to leave it like that. Let's say it asks you to do an improper fraction. You would enter it that way, but make sure you check how the program online, your math program, wants you to input your answer. If they want a mixed number, you got to fix it. If they want a decimal, you got to fix it. This would be if they ask for an improper fraction. So part of the test, part of testing is to see if you read all the directions. So if you do, let's say this is a test, right? And I put 36/7 and it actually asked me for a mixed number. I would give you partial credit back, but you could not ever receive full credit because it asked you for a certain form that you didn't do. Oh, how we do decimals? Decimals are coming up. Don't worry about it. That's next chapter, I think it is. So I guess it wouldn't ask you for decimals yet. So don't worry about that. It would ask you for improper. I didn't think about that. Very good. Decimals are next chapter. It won't ask you for decimals yet. It'll be improper or it will be mixed number.
How would you write 36 over 7 as a mixed number?
Okay, so how many sevens go into 36? 7 times 7 is 49, 7 times 6 is 42. 7 times 5 is 35, right? Okay, so 5 is 35, and how many do I have one left over? I have 1 over 7. And if you don't like that way, you'd actually divide them, long division. You would do this, 36 divided by 7. Okay, so 7 times 5 is 35. I have 1 left over. And then if you can see it, this is my 5. This is my part, my 1, and this is my whole, my 7. 5 and 1/7, like that. So either way, division always works too, because you can see clearly that this is my whole number, this is my part of my fraction, and this is my whole. So any remainder, if you think of remainder is going to be your numerator, and whatever you're dividing by is going to be your denominator. It's a really good question too. Two, 9/4 divided by 2. This can be a little tiny bit tricky, but remember 2 is really over 1. You always want to do that when you are dividing. Make sure you put it over 1 because we got to flip it. So we're going to keep the first fraction. We're going to change it to multiplying, and we're going to reciprocate or flip the second fraction. So 2 over 1 now becomes 1 over 2. And now we are just multiplying. 9 times 1 is 9. 4 times 2 is 8. I'm going to write it as a mixed number. Let's say it asks me for a mixed number. How many 8s are in 9? 1. How many are left over? 1. Or you could divide them and go, there's 1 8 in 9. There's 1 left over. So I can see this is my whole. This is my top of my fraction, and this is my denominator. 1 and 1/8.
So when we write our improper fraction, it would always keep the bottom number the same.
Yeah, exactly. Exactly. Yep. Always stay the same. That's your whole. That's always going to be the same. The part of fraction that's a whole, that's going to be the same, unless you can simplify it for somehow. Or maybe you forgot to simplify it. You can simplify at the end if you have to. But that's totally simplified, so we can't, there's nothing to do. All right, so let's try one with a variable. Just slowly get you used to variables. And number 1, we got to change it to multiplying. So keep the first fraction, change dividing to multiplying, and reciprocate or flip the second fraction. If we cross simplify, which I see I'm going to, not everything needs to be, not everything is simplified that way. Sometimes it is simplified, nothing to do. But I see 3 and 9 this way. I can divide both of them by 3. And then I look this way and I see 2 and 10. I can divide both of them by 2. So 2 becomes 1, 10 becomes 5. And by the way, if you like this and you like this way of doing it, I would suggest a different color pencil, because if you do it all in black, sometimes you forget, you don't understand what number's what. But see how the numbers I did it in blue for a reason. They stand out. I know my new numbers because they sort of stand out. They're not blending in with my black numbers. They're blue and I can see them. So I have 1x times 3y. Okay, so an x times a y is just an x times a y. That's all it is. So it's just 3xy. That means all multiplying is 3 times x times y. I don't think we have done something like that before, but but it just multiply together, it's just 3xy. And then denominator would be 5. 1 times 5 is 5. All right, question on that one. We're gonna do something with X's and Y's in a minute, but right now they're just hanging out. That's the answer. Total answer, nothing else we can do. I'm gonna show you ones where we can simplify the X and Y in a little bit. Okay, so I want you guys to try one. I want you to try this one. 1/3 divided by 8/9. Give it a try. Okay, I'm doing it real quick. You don't have to cross simplify, but at the end, you'll get the same answer. If you don't, and that would be 3/8. Do you get 3/8? Yay. Okay. Let's try one with a variable, just so you can practice. Let's do 5x over 8 divided by 5y over 6. And again, the X and Y are just going to be there. Don't let it mess you up. Just think about the numbers. I'm gonna start doing it, but keep going if you're still doing it. Don't look yet. All right, answers up. How'd you do? Yeah, good. I see good. I see like frowny faces. Okay, so if you have a frowny face, just look, see what you did. Ask me a question if you're not sure.
I got 6x over 8y.
Okay, so all you have to do then, you're right. It said it's not simplified. All you have to do now is divide both of them by 2. Because I could divide 6 by 2 and 8 by 2. And then you'll get your 3x over 4y. You're just one step away, that's all. Anybody else? Always ask yourself, are you completely simplified? I sort of kind of like, I forget sometimes that I know in my eyes that I know when it's simplified, but sometimes if you get something like this, just take one extra look and just say, can I divide by anything? If the answer is yes, you got one more thing to do. All right, so I got a good one. Ready? Here's my question. How do we do this one? Oh, it's going to be a good one. 2 and 5, 6 divided by 3 5/12. Ooh. How do we do that one? Anybody have an idea? How you think you would do that? I wouldn't leave it in this
Turn it
form.
into a new proper fraction.
Yes, you make it in proper fraction first. Yay, Josh. Okay, good, 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 good. Okay, you have to make it in proper fraction first. Fraction first. Okay, so remember how to do that, right? So we go like this. We multiply that and we add that. So we have 6 times 2 is 12 plus 5 is 17, 6 divided by, we're going to multiply that and add that. So 12 times 3 is 36 plus 5 is 41. Did I do it right? Yeah, 41 over 5. Now, we are going to now do keep, change, flip. Because we changed it to improper fractions, now we're
Why-
going to do keep, change,
Why
flip.
would it be over 5? Why would it be over 5?
Oh, it's not 5. It's over 12.
It
Because
would be 12, yeah.
I looked at the wrong thing. See how easy it is to do this wrong? Yes, thank you. Yes, it's not. I'm glad you pay attention. It's not. All right, equals. Keep, change, flip. Keep, change, flip. And now I can simplify and see if I would have messed me up because I knew there's something simplified. So I can cross simplify this way. And I know, let me change my color. This 6 divided by 6 is 1, 12 divided by 6 is 2. I don't think 7 is 14. No, I cannot do 17 and 41 have nothing in common. So we're going to multiply across. 17 times 4 is 34. And 1 times 41 is 41. And I have my answer. And then always say that one last thing, like, can I divide both of them by something? And there's nothing else. Okay, let's do one more like that because you will see this for sure. -2 2/3 divided by 8 5/6. All right. Get them to be improper and stop, and then we'll continue from there. But I want to see if you guys are all right getting them to be in improper fraction first. Okay, so I wrote it down. See if you got what I got. This is just the improper fraction part.
I got -4/3, not -8.
Okay, so you want to multiply that to make -6 plus the 2, which will make your -8.
I thought it would be -8 if you were subtracting.
Okay, now the negative, don't think of it as a negative like stuck with, the negative's out front. It's just gonna hang out in front. It's not really stuck to those numbers at all. So you're not subtracting anything. You're always gonna multiply and add. That negative just hanging out in front. It's not part of the mix of like you multiply and then you add and subtract them. It's not like this. It's not -6 plus 2. It is not. It's just a negative in the front and you're just gonna multiply. I want to put that. You're just gonna multiply the 3 and 2 and add the 2 and put the negative in the front. It's like not part of the mix.
So I
It's
should
not
be
part.
looking at the whole fraction as a negative compared to just one number.
Yes, exactly. It's not one number, it's a whole thing. Yeah, it's very separate. Okay, so now, that's a good question. I didn't even think about that. Okay, so now, keep, change, flip, right? Try it. Now that I know we all have the same thing, try it. Give it a try. Don't look, so I'm doing it too, but do it on your paper. And when you're ready, I have the answer up. All right, so how we do? Good, good. I see good things. I see good signs. Yes, I see shaking heads. I see fingers. Yay, yay. Okay, so one more thing for the section. One more thing. And the next section, we have like 20 minutes left. The next section is really, really small, so we're good. Adding and subtracting fractions, but the most basic kind. Our next class, we do the ones that aren't the same denominator. So that's one we need time for. So this one's really fast. All right, so let me add a page. One more thing. All right, now we're gonna put it all together. Okay. Put these all together. Okay, so we are going to do like order of operations, right? Times 9/14 divided by 7/15. Whoop, bad 15. Okay, so it's like any other order of operations, we have to do parentheses first. But I'm gonna do cross simplifying first. So I know if I go this way, I can divide both of them by 3. I didn't mean to erase it. Hold on. Sometimes my thumb hits the wrong thing and it goes off. Okay, there. Oh, there you go. That becomes 1, that becomes 3. I also know I can do this way and divide by 2. Don't forget that negative's there though. That's 1 and that's 7. So before I even simplify it, I'm going to rewrite it. So really I have -1/1 times 3/7. That's what I have when I simplify. I guess I don't have to really rewrite it. I'm just gonna put the answer in. Forget it. I'm not rewriting it. Okay, I know it's a negative. 1 times 3 is 3. 1 times 7 is 7. Now I'm dividing that by 7/15. That is just keep, change, flip. So keep, change to multiplying, and flip to be 15/7. And now I'm going to do my little, can I simplify anything? 3 and 7, I can't simplify that. 7 and 15, I can't simplify that. So I have nothing to simplify. So we just have to multiply across. Don't forget the negative though. So first thing first, negative times a positive is a negative. So I'm going to put my negative here. So don't forget it. Then I'm going to concentrate on my numbers. 3 times 15 is 45. 7 times 7 is 49. And that's my answer. I don't like when I do that. I really like doing this a lot because that's how you're going to see it on your math lab a lot, the negative in the front. You're not going to see it in the top or bottom. It's going to be in the front. Is it wrong to put it in top? Absolutely not. But I do know math lab doesn't really do that. They sort of do it in the front a lot. Can you enter it this way in math lab? Yes, there's nothing wrong with this at all. 2. I have so many of them here. Okay, 6 over 11 divided by 2 over 22 times 4 over 9. Now, I don't have parentheses, but I have to use my order of operations, so I have to do my dividing first. So, but I can't divide because we don't divide fractions, we multiply by reciprocal. So I'm going to fix this, whoops, I'm going to fix this first. So keep, change, flip. I'm going to write all of it down. That's really my new problem. That's really what I'm doing. I'm multiplying and multiplying. Okay, so now I'm going to add parentheses for myself. I'm going to do this first and then multiply the 4/9 after. So that's my parentheses, just so I keep myself focused on what I'm doing. So I'm going to cross simplify here. I can divide them both by 11. That's 1 and that's 2. And I'm going to look here and I can cross simplify there, divide by 2. That's 1 and that's 3. So what do I really have? Well, I have 3 times 2 is 6 over 1. So I really have, I'm going to leave it that way though, 6 over 1 times 4 over 9. We're doing fractions, so keep it as a fraction. Now, I can multiply across and simplify, but I can simplify first too. So I have right here, I see this right here. I can divide both of them by 2 or 3, sorry. I can divide them by 3. If I divide that by 3, I have 2. If I divide this by 3, I have 3. And now I can multiply across and I get 8 over 3. And let's say it asks for a mixed number. Then it would be how many 3s are in 8? 2. That makes 6. How many are left over? Out of 8, 2. 2 2/3. Or you could divide them and go, okay, that's 6. I have 2 left over. That is 2 2/3, whichever way you like better. Questions? Just remember when it's multiplying and dividing, it's whatever comes first, unless you have parentheses, and then you always do your parentheses first, of course. Okay, so let's spend the last like 11 minutes on the last section, which will get us ready for what we're doing next anyway. And this section is real small. I'm doing a new page, it's just new. Okay, so 4, 4. 4, 4. Adding and subtracting like, that's what they call it, like fractions. It also has least common denominator, but in the title and at the end of the chapter, it does have least common denominator, but I want to do that when we have not like fractions. So I'm going to do it next time because there's no sense of talking about getting common denominators when we don't have to. This section, we don't need common denominators. So I'm just going to get right to the point, adding with like denominators. So that means something like this, add or subtract, add or subtract. Wait, I'm going to do both. I forgot. Add or subtract. How do you add and subtract fractions? Well, here's an example. What is 6 over 13 plus 2 over 13? So this is different than multiplying and dividing in the fact that you can only, right here, you have to have the same denominator. Same denominator is needed to add, subtract fractions. Then when you have the same denominator, you add or subtract whatever is given the numerator and keep the denominator. You do not change the denominator. You don't add them, you don't subtract them. Denominator. So when you add or subtract, you're only adding or subtracting the numerator and keeping denominator, but the denominator has to be the same. That's what's called like. This whole section is having the same denominator. It's already done for you. The next section, when we come back next week, we're going to have different denominators and we have to make them the same. So something like this, I'm just going to add across. 6 plus 2 is 8, and I keep my denominator of 13. And of course, you want to make sure it's simplified, but it is. I can't simplify anymore. That's simplified. I want to do this. 5 over 8x minus 2 over 8x. Now, are the denominators the same? Yes. That just means it just stays. So 5 minus 2 is 3 over, they both have 8x, 8x. I can have a whole bunch of them, like 20 over 11 plus 6 over 11 plus 3 over 11. They're all the same denominator. I don't have to do anything except add the numerator and keep the denominator. So 20 plus 6 is 26, plus 3 is 29 over 11. Or if it asks for you, I'm going to leave it as an improper. Let's say it asks for improper. As your improper, or they ask for mix, you would change it to a mixed number by dividing. Four. 2/5 minus 7/5. Yes, we can have a negative answer. Notice it's the same denominator. That's going to stay the same. But what is 2 minus 7? Well, that would be -5. That's my numerator. My denominator is 5. But now I can simplify. I can divide both of them by 5. So my answer is -1. Because it's really -1 over 1. I probably should have written that down. Hold on. So let me not skip a
I have
step.
a question.
Mhm.
I'm just kind of trying to get a hold of learning how to do mixed numbers. So number 3, would it be 2 and 7 over 11?
It'd be 2. Let's see, 2 is 22. Yep. That's it. 100%.
Okay.
Good.
Sorry.
Good,
Thank
good.
you.
I'll just keep showing both. I should have showed both. 5. Now, you have to be very, very, very careful when we have a variable. For instance, like this. X over 3 minus 2 over 3. So we don't have two numbers in our numerator that we can put together. We have an X and we have a number. They are not like terms. We cannot add them or subtract them. So how do we keep them? We go like this, X minus 2 over 3. Okay, these are not like terms and cannot be simplified. You have to keep them separate. They must stay separated. Six. And then be careful of a problem like this. Just like integers, just now it's a fraction. Hey, I see minus a negative, right? So what's opposite? Remember, this means, this means opposite of a negative 10 over 12. Well, that would be a positive 10 over 12, or you know that two negatives make a positive, but I have to rewrite this. This is really 5 over 12 plus 10 over 12. So minus a negative means plus. Opposite of a negative 12 is a positive 12. Now I can simplify it. 15 over 12, but I can divide them, can't I? Yes, I can. I can divide both of them by 3, simplify it. So 15 divided by 3 is 5, 12 divided by 3 is 4, and then that's an improper fraction. If I wanted that proper fraction, how many 4s are in 5? 1. How many left over? 1 1/4, or you could divide them. So either or would be your answer. Okay, and I have 2 more little problems to do with you, and then we're good, right where we're supposed to be. All right, I want to talk about perimeter a little bit. When you have a perimeter of a figure, you're adding all sides. We did this already before, but I just remind you because we're going to do a problem with a perimeter. Okay, this is supposed to be a square. Picture as a square, it's supposed to be a square. Okay, and I have one side is 3 over 20 inches. What is the perimeter? Well, I only gave you one side, but what we know about a square, all the sides are the same, right? So really, it just be 3 over 20 plus 3 over 20 plus 3 over 20. They're all the same. Or if you want to do a condensed version, you could say, oh, each side is 3 over 20 and there's 4 of them. You could multiply by 4. It doesn't matter how you think about it, whether you think of it 4 times 3 over 20, or you think add 4 of them, it's the same answer. 12 over 20, I can simplify that. That also would be 12 over 20 because I put it over 1. And if I take 12 over 20, I can divide them both by 4. And I get 3 over 5 inches. So if I add 3 over 20 4 times, I get 3 over 5 inches. Now, same idea. Let me put this as put that as number 1. I'm going to do one more. Same idea, but now it's a rectangle. So this is a rectangle. I still want the perimeter. Now, rectangle, I have to give you 2 sides, but remember that the opposite sides are the same. So if I want the perimeter for this one, it would be 3 over 15 plus another 3 over 15, because 3 over 15 is really on the other side, plus 4 over 15 plus another 4 over 15. Or you could have realized that it's just double. You could have done 2 times 3 over 15 plus 2 times 4 over 15. I don't care which way you think of it, whatever way you want, it's going to get the same answer. And each one is going to get 9. So 3 plus 3 is 9, 4 4 is 8, 17 over 15, which would be a mixed number, be 15. How many 15s are 17? 1. How many left over? 2. And centimeters. And then the only thing in this section we didn't do is a common denominators, but again, I really don't want to do them separate from what doing them together. I like to teach that when we start doing unlike denominators. So we're going to do that section when we do adding unlike denominators next time. Hey, any questions? I'm here. It's
17.
Yeah, I got 14 over.
I
15.
also got 14.
Maybe I added wrong. Yeah, I probably added wrong. I did 3 plus 3 is 9. Did you hear what I said? 3 plus 3 is 9? Yeah, how about we do this again? That's called me rushing. See what happens? Yeah. Mm-hmm. All right, so I got 14 over 15. How's that? Is that what you got? Yeah.
Yes.
If you go back to the tape and you listen, 'cause I know exactly what I said. I said 3 plus 3 is 9. I remember saying that. Yeah. See? Not concentrating